Hello everyone. So this is our O-level chemistry class. The chapter that we were talking about was acid-base salts, and today our content is about the preparation of salts. Okay, so we will be talking about preparation of various types of salts. Okay, various types of salts we will be talking about. Okay. So, first of all, in the last class we talked about the solubility of different types of salt. To know that how to prepare a salt, you must first have the knowledge about the solubility of different types of salt. So, if you didn't watch that video, or if you don't know, or if you have no idea about the solubility of salts, I would suggest you to go back to the first video of acid, base and salt and have a look at the last portion. Okay, so let's get started. Okay, so firstly we would see that how to prepare soluble salts. Okay, so in this case I will be consulting about some process which may or may not match with the books, but I will be but I am trying to present here a simplified version of preparing different types of salts. All right. So, now firstly we will be talking about how to prepare soluble salts. Okay. So, preparing soluble salts has got many ways. So, before knowing that how to prepare a soluble salt, we must first know that, for example, we are given a solution in which a salt is dissolved. Okay, we are given a solution in which salt is dissolved. Okay. So as we were saying, suppose a salt is dissolved in water, okay, and forming a solution. Now I ask you to take out the salt from this solution. Okay, take out the salt. So I am asking you to take out the soluble salt from the solution. Okay, if the salt was insoluble, like sand is mixed with water, that would be so much easy to separate the sand from the salt, from the solution or from the water. But if the salt is dissolved in water, then it requires some scientific process to separate the salt from the water. Okay. Now, how to do it? You must remember this by a meme. Okay, so I wrote something, but let me explain this to you. You can write it as English Cricket Club Fielder. Okay, FILDR. Okay, let me write it by changing colors. So English Cricket Club Fielder. Okay, so English Cricket Club Fielder, and the full form is evaporation, check with rod. Okay, evaporation, check with rod, cool, then filter, and then finally dry. Okay, so English Cricket Club Fielder means evaporation, then filtration, evaporation, then check with rod, then crystallization, cool, then filter, then dry. Okay, and these two C's over here is the combination of what we call the crystallization. Okay, all right. Now let's go into details that for preparing soluble salts, why do we need to follow these steps? Okay, so let's look at an example. Okay, so here I have some home components I'm presenting over here. My lab is a lot far away from my home. I can't go over there right now because it's a corona epidemic situation. So let's see. Okay, this is a glass. This is a glass, and I'm taking some water inside it. Okay. Okay, so here I take some water inside it. Okay, here you go. The glass now has water. Okay, and then what I do is that this is the salt. All right, so I am taking salts here. Okay, this is sodium chloride, the salt, also called the table salt. Okay, and we are dissolving the salt in the water. Okay, like this. So here we go. Look, the solution is completely almost clear. That means all the salts has dissolved in the solution, isn't it? Now so sodium chloride is a soluble salt. All right, now my question is, how would you separate the sodium chloride from this solution? Okay, so what we have to do is that E English Cricket Club filter, so ECCFD, first we have to do evaporation. Okay, so I am putting it inside a container. In Bangla we call it hari. Okay, and I am turning on the stove and making it as okay, let me make the process fast. So look, this solution has got dissolved salt. Okay, now let me let the solution be evaporated. Okay, let's wait for some time. Okay, look, the evaporation of the solution has started. All right, the solution has started to evaporate. Now let's wait. Okay, so the solution is evaporating violently. Now let's put a rod, a steel rod. Glass rod is more preferable, and putting it in this solution and holding it to check that whether salt has started crystallizing. No, not yet. And putting the glass rod in. Okay. Okay, so here I take the glass rod out. Okay, so here I have got some salt crystals collected. So salt has started forming into the solution. Okay, now why does this happen? We are going to tell it very soon. So our glass rod, this rod indicates that salt has started to formed or to come out from the solution. Okay, so let's put it aside, and it's evaporating so much. So since salt has started to be collected, so now let's turn off and let's wait for the solution to cool. Okay. Okay, so we have waited for such long time. The video was being paused. Now let's look into the solution. Look, can you see the salt into the solution that has been produced at the bottom of the container? Okay, so there's the water remains, and there's the salt produced at the bottom of the container, and some more salts is waiting. Look over here. I think you can see it, that some more salt crystals are just, oh, you can blur. So some more salt crystals are waiting over here and yet to be formed. Look, these granules are the salt crystals. Okay, these all the floating things are also the salt crystals that will soon fall at the bottom of the container, and these are the salts that has already been collected. Okay, so how do we know that salts have been formed? We have put the rod when the solution was evaporating. Okay, turn off the camera. When the solution was evaporating, we have put a steel rod into the container to check that whether salts has started collecting to come out from the solution. And then what we have got? We have got some salt granules on the rod, but in these cases, instead of steel rod, glass rod would have been more better. Okay. So now what we will do, we will collect the salt produced by what we will do, we will filter, collect by filtration, collect by filtration, okay, and then dry it in an oven or by putting it under the sun. Okay. So this is how salts will be produced. Okay. Salts will be collected from solution. Now, how to we have till now we have learned that how to take out the salt from the solution, but we haven't yet learned that how to produce the salt or how to make the salt. Okay. So we have to learn this now, that how to produce the salt. Okay. So what we have to do is to produce soluble salt, it requires many things to be considered, and just remember for simplicity that the most efficient way of producing soluble salts is by the use of acids. Acids for the negative part of the salt, acids for the negative part of the salt or negative ion of the salt, and either metal or we can use metal oxides, okay, or we can use metal hydroxide, okay, who is this, or we can use metal carbonates to produce the salt. You remember that salt is a part which is produced from the reaction of acid with metal oxide, metal hydroxide, or metal carbonate. Okay. Okay, so which one to choose? Which one is we need to choose? Okay, so for the positive part we have to use these things for the positive part of the salt. Okay. Now, what are the methods that we can use to prepare the soluble salt? The first method we can do is the titration. We can follow the titration process or addition of metals or their hydroxides or their oxides or their carbonates in excess. Okay. So these things, the metal or their oxide or hydroxide or carbonates has to be in excess to, added in excess amount to limited amount of acid. Okay. So, with limited amount of acid, we would add either excess metal or excess metal hydroxide or oxide or carbonate with limited or small amount of acid. So, this is one method, but this method usually work in all cases and does not work in some cases, and for those cases we have to use the titration method. Now, let us see what to do. So, this method, that adding, please note it down, adding excess metal or metal hydroxides, metal carbonates or metal oxides with limited amount of acid works if the metal or metal hydroxide or oxide or carbonate are insoluble in water. Okay. Please stop the note. That means, if the metal oxides, hydroxides or carbonates or metal itself are insoluble, if they are insoluble, then it will work. Okay. If they are insoluble, then it will work, but you must keep this in mind that this has to be insoluble. Okay. So, what we will do is that number one, start noting down, add or continue adding the solid, and then inside a bracket write metal or metal oxide, metal carbonate, metal hydroxide, and then close the bracket. Okay. So, solid and then bracket are added in small portions with the acid, are added in small portion with the acid. Okay. Number 2, if all the acids has reacted with the solid, if all the acids has reacted with the solid, then unreacted solids will remain at the bottom. Unreacted solids will remain at the bottom, indicating that all acids has reacted. Okay. So, this is point number 2. Now, let us go to point number 3. Now, filter out the unreacted solids. Filter out the unreacted solids. Number 4, the solution that remains now contains the soluble salt. The solution that remains contains the soluble salt. Number 5, then that English cricket club filter. Okay. English cricket club filter, that means evaporation, check with rod, cool, filter and then dry. Okay. Okay. So, so why do we are adding excess base or excess solid over here. This is to make sure that all the acids has reacted. Okay? And when insoluble and when unreacted solid remains on the bottom, we are ensured that all the acids has reacted and there will be no more reaction. Okay? And the base and the solid will also not interfere with the salt, because the solid is insoluble. So, it will settle down at the bottom. So, it does not interfere with the salt, or it does not change the quality of the salt. Okay? Let us analyze. Let me show you an illustration. Okay, I am taking 1 and 2, 3. So, I am taking 3 sets of beakers. Okay, so here into the beaker we have solution. Okay, solution. Okay, so this blue colored thing is the acid, for example. Okay, now now what's going on is that I'm putting some solid. Okay, this is a small amount of solid. I'm putting some solid inside it, and then what's going on is obtained that we have obtained this. All right, that means this has become dissolved into the solution. Okay. Okay. So we have obtained a clear solution. That means maybe there are more acids remaining. Okay. So now we put some more solids into the solution, and what we get is this. That means this solid has again dissolved into the solution. That means it has undergone reaction. So now we put some more solid into the solution, Now what we get is this. Okay, so this means that all the acid into the solution has reacted, and there are now some unreacted solids. Then the solid is metal oxide, metal hydroxide, or metal carbonates. It can be anything. So this is how it will work. Okay. Okay, let me give arrows. So from here to here, then here to here. Okay, so here is the finishing part. Okay, then what we will do is that we will carry out filtration over here. Okay, we will carry out filtration over here by using the filter paper. You know the how to use the filter paper, you already know it. Okay, so this is funnel, and this is a beaker, and I have put the solid and I have put the solution over here from the last part, and then we have the insoluble parts over here, and then okay, and suppose this is the filter paper. Okay, and then what will happen is that the solution will settle at the bottom, or will fall at the bottom from here. Okay, and the solid will remain, over here. Okay, so the ultimate result would be like this. Okay, let me rub it. So here drops are coming down from here. Okay, okay, now so what will happen is that this is a filter paper. So the unreacted solid will remain here, and the solution will fall down at the bottom, and this part of the solution contains the soluble salt. All right. Okay. So now after we have got the solution of soluble salt, we will carry out ECCFD. Okay. Okay. Anything that is available, any solid if available, we can carry out the a reaction. That means adding excess amount of solid into limited amount of acid. Now, if the problem is that when the oxide, that means when the metal oxide or the metal hydroxide, I'm just writing OH, okay, metal oxide or metal hydroxide or the metal carbonate is soluble in water, the problem starts to grow. Okay, so the problem is that, the theme is that if these are soluble in water, then even if inside the solution they are present in excess amount, suppose you are adding excess of the solid, okay, you are adding excess of the solid into the solution. So what will happen is that even if the amount of solid is excess, it will still dissolve in the acid, but this time without reacting, it will just dissolve. Initially it dissolved because it reacted with acid, but now it will just simply dissolve because of its solubility. Okay, because it is soluble in aqueous solution or in water or in acids. Okay, so there lies the problem. So in these cases, what we will do, that if the metal oxide, the metal hydroxide or the metal carbonates are soluble in water, if they are soluble in water, then they would also be soluble in acidic solutions. Okay, it's a general theme. So if these are soluble in water, that means if the solids, that means the bases, are soluble in water, then we will carry out the method of titration. Okay. Now, what is titration? Titration is a very brilliant method of finding the extent or completion of the reaction between two soluble reactants. Okay. For example, you are considering that the reactants are soluble, so and they're also colorless, and so you won't be able to determine that okay, they are reacting, but when is the reaction finished? Like in case of the solids, when they were insoluble, you can indicate that the reaction is finished when there are insoluble residues or solids falling at the bottom of the solution, indicating that no more solid will react because the reaction has finished, all the acids has reacted. But if they are soluble, then you won't be able to determine that whether the reaction has finished or not. Okay, so it's a very good method. Titration is a very good method to indicate that how much reactants or soluble reactants are required for reacting completely with each other. Okay, let me tell you something. What happens? Suppose I am taking two liquids. Okay, so liquids. Okay, now first let me give you idea. Okay, for example, you are taking a beaker, and inside the beaker you have put a solution. Okay, you have put a solution, and then you will put one indicator, and the indicator will change color when the reaction is finished. Okay, just imagine it in this way. For example, this is the indicator remaining at one side of the solution. All right, and the indicator color is red. Okay, and now you are adding this green colored solution into the blue colored solution. Okay, now you are adding, and then finally what you have got is that after a certain time you have found that the indicator at the top has changed its color to blue, just changed to blue. Okay, just the color has been changed to blue. Okay, for example, over here 30 cm cube of solution is present, and you are adding the green colored solution. Okay, and just after you have added 25 cm cube of the green colored solution, the color of the indicator has changed. Okay, so what we can conclude from here is that 30 cm cube of blue solution needs 25 cm cube of green solution. Okay, so this is what we can conclude. Okay, so now what we will do is that we will make a ratio. So the ratio of blue is to green is 30 is to 25. Okay, or we can tell it as 6 is to 5, anything. Okay, so here now we get to know that in what ratio will the two solution react. The two solution will react in the ratio 6 is to 5, that means 6 blue and 5 green. Okay, now we mix the solutions in the ratio, and we are now quite sure that so the proportion of the solution that we are mixing are now has undergone complete reaction and nothing remains. Okay, so we have to employ the use of indicator to indicate that the reaction will be finished. Okay, so this is what the titration is. Okay, so what we will do is that, so first, number 1, please write the note. Take a certain volume of a solution, take a certain known volume of a solution. This is number 1. Then number 2, add small amount of indicator inside the solution. Number 3, continue adding a second solution. Continue adding a second solution. The second solution in this case is like the green, and the first solution is the blue. Okay, so continue adding the second solution into the first solution until the color of the indicator just changes. Until the color of the indicator just changes. Okay. Number 4, record the volume of the second solution needed. Record the volume of the second solution needed to react with the measured volume of the first solution. So, if the measured volume of first solution was V1 and the recorded volume of the second solution is V2, then go to number 5. Then calculate the ratio of the volume of solutions. So, V1 is to V2. Number 6. Now, what we will do is that mix solutions in a separate container according to the calculated volume, according to the calculated volume ratio. Mix solutions in a second container according to the calculated volume ratio. And number 7, then A, C, C, F, D. Okay, A, C, C, F, D. Okay, so that's how to prepare soluble salt. Now, when again, that how will you determine that which method to use for producing the soluble salt? Okay, just remember that for the negative part we have to use acids, and acids are always soluble, and for the positive part we have to use the metal or metal oxide or hydroxide or carbonates. And if these solids are insoluble, then we will use the first method. That means add excess base in limited acid, add excess solid in limited acid, and if the solids are also soluble, then we will employ this method of titration. Okay. Okay. So, okay, now for simplicity, I want to tell you that for shortcut or save time, if you see that the positive part of the salt has sodium, potassium or ammonium, then we have to use titration because all their compounds are soluble. Okay. Okay. Let me give some examples. Like you have to prepare magnesium chloride. Okay. So this is the chloride, the negative part. For the negative part, we will take acid, the hydrochloric acid, and for the positive part, we can use metal or metal oxide. We can use magnesium directly, or we can use magnesium oxide, or we can use magnesium hydroxide, or we can use magnesium carbonate. Okay, anything. But all these magnesium salts, the magnesium compounds are insoluble. If you do remember that all oxides, hydroxides and carbonates are insoluble except sodium, potassium and group 1. So these things, or this thing is, are insoluble. So what we will do is that we will take limited amount of the acid, okay, and inside the limited amount of acid we will add excess amount of these things and then carry out the steps as required. Okay. We'll give a worksheet on salt preparation. So this is what we had for the preparation of soluble salts. Now the preparation of insoluble salts. Preparation of insoluble salts. This is the easiest of all. Here no ECCFD is required. Here just F and D are required. ECC is not required. Okay. Okay. So oops, what just happened? I don't know. Sorry. Okay, so we were just learning that how to prepare insoluble salts, and preparing insoluble salt has just got a simple step. Okay, we have to take two soluble compounds to produce the insoluble compound. Okay, why two? You know that a chemical compound has got two parts. One part is the negative part and another part is the positive part. So for the negative part we have to take one soluble compound, and for the positive part we have to take another soluble compound. All right. So look here, again and again solubility of salt is appearing as the case. So now if I say that you have to prepare an insoluble salt, which is the silver chloride. So for chlorine you may take NaCl. Okay, NaCl is soluble because it contains sodium. And for silver you can take nitrate, AgNO3. Okay, so if you actually forget the solubility of salts, then for the, let me tell you a shortcut over here, then for the negative part, take potassium or sodium salt, and for the positive part, take a nitrate salt. Okay, so this is an extreme shortcut, but sometimes this rule has got lots of variations. Okay, any soluble salt can be taken, and I'm just telling you or advising you to use this when you will forget about solubility of different kinds of salts. All right. Okay. Okay, so how to produce the insoluble salt? For example, you have to produce what we have told. You have to produce silver chloride. Okay, so what we will do is that we will take a container. Suppose this is the test tube, and inside the test tube we have taken small amount of the for example, this is call it sodium chloride. Okay, so this is the sodium chloride solution inside it. Okay, make it more thicker. So this is sodium chloride. Okay, and inside sodium chloride what we will do is that we will add silver nitrate dropwise like this. Okay, from a dropper. From a dropper we will add, this is silver nitrate, we will add silver nitrate dropwise into the solution containing sodium chloride. All right. Okay, then what will happen is that we will get the silver chloride, sorry, we will get the silver chloride solution at the bottom of the container like here. Okay, it will be automatically collected at the bottom of the container. Then what we will do, so this is silver chloride, so the top solution is sodium nitrate. Okay, so to collect the silver chloride we will just do filtration and drying. That would be enough. Okay, so that's how to produce the insoluble salt. Now what we are going to learn is writing various types of ionic equations. Okay, please give the topic that writing ionic equations of salt preparation. Okay, so please get to memorize that you should remember that the reaction of metal with acid is a redox reaction rather than being a neutralization reaction. Okay, so first let's write a redox reaction between metal whose valency is suppose X, metal having a valency X. Okay, so this is a metal which will soon react with the acid, and acid contains H plus. Okay, so acid contains H plus. Okay, now what will be the reaction? Let me tell you. Okay, so the reaction would be like M plus X, and then we will have H2 over here. Okay, so the formula would be, if the valency of metal is X, then we need X amount of H plus. Okay, we need X amount of H plus, and we will get x by 2 amount of hydrogen. Okay. Okay, so this is the ionic equation for the reaction between metal and acid. The hydrogen ion came from the acid. Okay, all right. Number 2, the acid base reactions or neutralization reactions. We have already learned this in the first video, which is like the oxide ion would react with two hydrogen ions to form H2O. The hydroxide ion would react with one hydrogen ion to form H2O. Okay, and the carbonate ion would react with two H plus to form CO2 and H2O. Okay. Okay, so these are all the neutralization reactions or the acid base reactions. Okay, now let's go to number 3. The precipitation reaction is the easiest way to write. It's like just if a soluble salt is and the insoluble salt is, suppose I'm telling you the insoluble salt is PbCl2. Okay, so the ionic equation would be, just write these as ions. So Pb2 plus 2Cl minus, this will give PbCl2. Okay, the components that are present in the insoluble salt, just put them as ions and write the ionic equation like this. Okay, so we had here lead. So we had here lead. Okay, we had lead over here, and we had chloride over here. So here we write the lead ion. Okay, and here we write the chloride ion, and here it is our PbCl2, the salt. Sorry, not this. So this is the salt. Okay, so to write the ionic equation for producing insoluble salt or for formation of insoluble salt, just put the elements in the elements or the substances in the salt as ions. So we have lead chloride, so we have taken a lead ions and the chloride ions. If I give another example, like barium sulfate. Okay, so this is also insoluble salt. So to write the ionic equation, we are just putting the barium ion and the sulfate ion. All right, and then we are getting the barium sulfate. Okay, so there is one more rule for writing the ionic equation, and we will discuss about it later. Okay. Okay, now let's move on to types of oxides. So types of oxides, or different types of oxides we will be dealing with. Okay, so it's very simple. We have metal oxides, and we have we have non-metal oxides. Okay, and we have what we call is okay, so we have these two types of oxides, the metal oxides and the non-metal oxides. Okay, So metal oxides are all usually metal oxides are usually they are all they are all ionic, and you know metal oxides, they react with acids. Sorry, they react with, yes, they react with acids. That's why the metal oxides, they are all base, because only base react with acids and the metal itself. Okay. Some exceptions of metal oxides are there. Some exceptions of metal oxides are there who react with, okay, we will talk about it later. Exceptions talk about later. And we have non-metal oxides, which are all covalent, that means they have all covalent bonds within them, and they are all acidic. That means they would react with bases, and so they are and you know that acids react with bases. So since non-metal oxides, they would react with base, that's why they are acidic. Okay. And now the exceptions. Exceptions. We have okay. So exceptions. Okay. Some metal oxides are there. Some metal oxides are there, like we have zinc oxide, lead oxide, then aluminium oxide. They are also metal oxides, but they react, these metal oxides react with both acid and alkali. Usually we know that metal reacts with acids, metal oxides, they react with acids, but these metal oxides, they react with both acid and alkali. Okay. So that means that's why they are given a special name, which is the term amphoteric. Okay, amphoteric. Okay, so metal oxides are usually basic, that means they react with acids, but the exceptions of metal oxides, please note it down, the exceptions of metal oxides are amphoteric, that means metal oxides which are exceptional, they are amphoteric, that means they react with both acid and alkali. Okay. Now the exceptions of non-metal oxides. Exceptions of non-metal oxides. Non-metal oxides are never basic, but all their exceptions are neutral. And which are neutral? Let me tell you. It's the monooxides. Monooxide means containing one oxygen in the compound. And the dioxides and trioxides, they are all acidic. Monooxides are neutral, like CO, the carbon monoxide, then H2O. Look, here is also one oxygen, so this is also neutral. Okay, so these types of oxides, the monooxides, they are all neutral. Okay, non-metal oxide, so they are all neutral. So the exceptions of non-metal oxides are all neutral, and the neutrals are the monooxides. That means mono non-metal oxides. Sorry, non-metal monooxides. Okay, now Okay, so guys, that's all for today. That we have almost finished the acid, base, and salt chapter. We are only left with the ammonia and sulfuric acid part, but we will prepare a different video for that. But till now, what we up to now, what we have studied, our acid, base, salt chapter has been finished. Okay, and if you want the worksheet along with answers, please contact with me through WhatsApp. Okay, thank you.